This video is going to be a step-by-step tutorial explaining exactly how you can create a looping animation using simulation nodes and get a particle system to loop. We'll be creating this particular abstract motion graphics loop that you can use in any project that you please. So let's figure out how we can create the same in simulation nodes. In our default scene, we'll bring our cursor to the junction of these two windows, click and drag to create a new window, and we'll change this from the 3D viewport to the geometry node editor. Then we'll press this plus button to create a new geometry node tree, after which we'll zoom in, select the group input, and tap X to delete it. Now essentially we just want a particle system that's gonna have particles that's going up in the Z direction. If you wanted to go at an angle, you could do that. However, I feel it's gonna be easier to keep it in the Z direction and just tilt our camera. So we need a plane from which these particles have to emit. So let's press Shift A and search for a grid, which is going to act as our plane, and we can simply plug the mesh into the geometry. Now we need to size up the grid to become the size that we want. For now, I'll just go with a size of 10 units by 10 units. This might be too big for what you're doing, or it might be too small, so it's up to you to choose a value accordingly. I'll maybe go with 5. Next, I want to distribute a bunch of points on this face, so I'll press Shift A and search for a distribute points on faces node and plug that in over here. Now we'll just add in a simulation zone so that we can have these move up in the Z direction. So let's press Shift A and search for a simulation zone and plug that in right here. So we have to plug the points into the input, and we can take this output and plug it into the group output. Now we can just search for a set position and plug that inside the simulation zone, and if we change the Z to something like 0.1, when we play the animation, it should start moving up in the Z direction, which looks perfectly alright. Now I think it's moving a bit too fast, so I'll go ahead and reduce this from 0.1 to 0.05, and now it just slowly moves up. Another thing that I want to do is set all of my animation defaults now itself, because changing the frame rate later on causes issues, and of course you could use the delta time to prevent those issues, but for the time being I'm just going to set my frame rate right now. So I'll go to my render properties and change my frame rate to 30 frames per second, and I'll change the end frame to something really high. Let's go with 600 for now, and then we'll continue with the simulation. So let's just see what happens. Right now it's all going up by 0.05, and I think it's still a bit too slow, and since I do want to render it out at 60 fps, I'm going to change this from 30 fps to 60 fps. Now when I play it, it seems really nice and smooth, and it's going up at a speed that I like, so I think this is what I'm going to go with. But there's only one set of points that are moving up. We need to add in more points. So to add in more points, you can just shift this to the side, press Shift A and search for a join geometry node and plug that in right after the geometry. Now we need to join in a new set of points, so we can take these points and plug it in. So then when we play this, you can see how there are new points being created every single frame, and the old ones are moving up. However, this looks way too uniform because the points are being distributed at the exact same places. So we need this seed value to change according to the frame number. So instead of controlling them using a scene time node as we've done in multiple previous videos, we're actually going to use a value node so that we can make this perfectly looping. So let's press Shift and search for a value node and plug this into the seed. Now we're going to have to keyframe the value such that we get the same value on frame 0 and the last frame, which is in our case 600, and we need a few keyframes in the middle as well. Apart from that, another thing that we need to note to make this looping is that we're not actually going to start from 0. When we were looping particle systems in the old way, we always had two different particle systems, one starting from a negative value and one starting from a positive value in the middle. But we don't have that flexibility in simulation nodes because we cannot start the simulation before frame number 0. That's why we're going to have to actually start the animation at a later frame. So since I want this to be like 5 seconds long and it's going at 60 fps, I'm going to actually render out my final render from frame 300 to frame 600. And the reason why I'm going for frame 300 is because I'm hoping that by the time we get to frame 300, there will be enough number of points created to cover up my camera view, and it won't seem like new particles are being created and they just end at frame 600 and the loop is broken. So that's why we're going to do this. Now what are the values that we're going to actually keyframe? So let's go back to frame 0, and on this value we'll just go ahead and tap I. Then we'll go midway through between 300 to 0, which is frame 150, and we'll change this value to something high. Let's go with 20, and then we'll tap I, and then we'll go to frame 300 and we'll change this value back to 0 and we'll tap I. Now we'll just select the node so that the keyframes appear down here, and we'll press T linear, and this is what we have to repeat again. So you could use modifiers to repeat it, but I think it's just simple enough to press Shift D and move it by 300 units, and that way you should have these numbers go from 0 to 20 and then go back from 20 down to 0. So when we actually play the animation, you should be able to see how these go up and how they come back down. Now this looks decent enough, but you see there's still randomness because it's not changing every single frame. The seed value is changing only 20 times between frame 0 to 300 because the seed value of the distribute points on faces has to be an integer. That's why it's a green color dot, but we're giving in a float value. But I don't think that's an issue for me because I don't actually want there to be this many points. I want only one set of points to appear. So that way we actually have to use this join geometry only once every 20 frames. So we have to figure figure out how to do that. Only once every 20 frames should these points be added in. Otherwise, we need to directly connect this geometry into the set position. But we can't do both of those together. That's why we actually have to search for a switch node so that we can switch between the different node trees and figure out which one to use. Now I'm going to keep this join geometry plugged into the true socket, which is down here. And if a specific condition is not met, then it's going to directly take in the original geometry that we had and pass it into the set position. So now what is the condition? The condition should be that the frame number is a multiple of 20. That way it will be a multiple of 20 only once every 20 frames. So to check if the frame number is a multiple of 20, we press Shift A and search for a scene time node so that we get the frame number from here. And then we press Shift A and search for a math node, and we change this math node from add to the type modulo. So what modulo does is it divides it by a number and gives the output as the remainder. So if the number is divisible by 20 and we divide the number by 20, we will get a value of 0. However, if it's not divisible by 20, then we will get some other number as this value. So let's go ahead and plug this frame into the first socket, and for the second socket we'll say 20 because we're dividing it by 20, and if the remainder is equal to 0, then we want this condition to take in the true socket, which is the join geometry. So we have to check if it is equal to 0. So for that we search for a compare node and we change this type from greater than to equal, and now we can just plug this value into socket A and we are checking if it's equal to 0. And this epsilon is like the allowable error for float values. If you don't want that, you can actually change this from float to integer, because at the end of the day, if the frame number is an integer and we're dividing it by 20, so we just want the nearest integer and we want it only if the value is 0. So any decimal value or anything does not matter. However, in case this gets rounded down to 0, you could search for another math node and search for a round up, which is called seal. So we can search for math and we can change this from add to seal, and that way we can make sure that it's 0 only when it is perfectly equal to 0. But another thing that you could do is not have this value at all and keep this from integer to float itself and just keep this epsilon value at a small number. It will yield the same results. Next, we take this and we plug this result into the switch condition, and now if we go back to frame 0 and play the animation, we should see one plane get created every 20 frames, which is exactly what we want, and this is going to be random. So if you go from the top view, you don't see any repeating pattern because they're all in random locations. So that seems to be exactly what we wanted, but they're still in the exact same plane. We don't want them to be in the same plane. We want them to have some type of variation in the Z direction. So what we can do is we can just shift this over to the side, and before we actually join in the geometry, we can go ahead and just shift them up or down on the Z axis. So we press Shift A and search for a set position node and plug that in over here, and for the offset we use just some random value on the Z axis. So we press Shift A and search for a random value node, and we change this from float to vector, and we keep the X and the Y values at 0 itself. Let's change both the maxes to 0, but for the min we change this from maybe a value of -1 to a value of +1, and then we plug that into the offset. So if we play the animation now, we get this sort of an animation which looks perfectly alright, and it should do. Only the first plane that is created will not have any variation, but I don't see that as too much of an issue because we're not going to be using that in our loop either way. The loop occurs only between frame 300 to frame 600, and it's always going to be working fair enough. Now you can see that as we start going towards the end of the animation, my frame rate starts dropping even more. So it was going at around 40 frames per second or 50 frames per second, and by the time we reached here, it can calculate only at 20 frames per second because there are so many particles being created, and my laptop has to count every single one of these particles and keep them accounted for. But obviously, since we're just gonna have the camera maybe somewhere around here, we don't need the particles to be present for this much of time. So we can delete particles that become older than a certain value. So let's go ahead and figure out how we can delete particles that become older than a certain number of frames. For that, we can just capture the age at the beginning. So we press Shift A and search for a capture attribute node, and we can just plug that in over here, and we're gonna have to take this same value and plug it into the set position instead of directly from the distribute points on faces. And essentially the age is going to be an integer, so we change this from float to integer, and we want it for every single point, so we keep this on point itself. And the initial age when it's being created is going to be a value of 0, so we leave this at the default 0. Now we can take this attribute and just plug it into the input of the simulation zone. So we plug it in there, and now we get this new attribute socket, and we have to change the name of the attribute to something that we can remember later on. So we can just tap N to bring in the side panel if it's not already open, and we'll change this to the node tab over here, and we'll also just select this simulation input node. When you scroll down, you should be able to see that we have geometry, which is one output, and we have another one called attribute. So we can go ahead and change the name from here by double clicking and calling this whatever we want. So I'm going to call this age. So now we have the age of the particles, and I can just take this age and plug it into the simulation output over here. And right now the age is not changing because we're just passing the age directly in. So every frame the age remains the same, which is 0. But if we want to start increasing the age, what we do is we add in an add node before the simulation output, and we just add a value of 1. So we press Shift A, search for a math node, and we just add in a value of 1, and that way every frame it becomes 1 frame older. So that is good enough. We don't actually see the values change. If you want to, you can always open up the spreadsheet over here and see the values change, but I don't think that's necessary. In case you do, I'll just show you either way. So we press Shift A, search for a viewer node, and now for the geometry we can directly plug in this geometry, and for the value we plug in this value, or we can plug in age. It doesn't make too much of a difference, so let's just take the age and plug it in. And now let's unhide it, and let's bring our cursor to the junction of these two windows, click and drag to create a new window, and change this to the spreadsheet. Now if you look at the point cloud, we have 1.5k points, and if you want to see the output from the viewer node, you change this from evaluated to viewer node, and that way you have a viewer socket over here which shows us what the value is. So from points 0 till how many ever points we are distributing on that face, they're all going to have a value of 111 because we're on frame 112 and they were created on frame number 1. As we move up each frame and we take a look at the viewer node, we just have to click it to refresh it. You see the age changes, and as we go down to the newer particles that were just created, which will be further down in the spreadsheet, you see how the age of those particles keep reducing and we get younger and younger particles as we go down. So those are how we use these attributes, but I don't necessarily need to follow them, so I'm just going to join this back and I'm going to remove the viewer node over here by tapping X. Now we need to delete the geometry based on the actual age. So I press Shift A and search for a delete geometry and plug that in right here, and I want to delete only the points that are older than a certain age. So I just check if this value is greater than some value. So I press Shift A and search for a compare node, and I'll plug this value into socket A, and the result I'll plug into the selection of my delete geometry, but I'm gonna have to change the B value to see if it is greater than what number. So I'm gonna say, is it greater than 200, so that anything that's greater than 200 frames old will be deleted. Even this might be too high, but it's all right. Beyond that, I also don't require this to be a float, so I'll change this to integer itself. So that way the comparison will be just a tad bit faster. Now we can go back to frame 0 to repeat the action, and nothing is happening because I did not change this from 0 to 200 over here when I changed it to an integer value. And now we can play it again, and we should be able to see that anything that crosses age 200 should get deleted. So once we reach frame 200, it gets deleted. So that's exactly what's happening, and that's good enough. We are going to keep our camera in this middle region where you can't really tell that there's something dying and something being created. So that's great, but I think there are way too many points now. So let's reduce the number of points by going back to my distribute points on faces and reducing the density from 10 to maybe 1. Now let's go back to frame 0 and repeat it, and this looks like there are fairly few numbers, but maybe I'll go even lower, 0.5, and that seems good enough for what I wanted to do. Next, on every single one of these points, I need to go ahead and instance these lines with rounded endpoints. So the best way that I think I can do that is by just instancing a curved line and two spheres on the ends of the curves. So that way the actual curvature of the endpoints remain the same and you don't have to worry about scaling that proportionally and things like that. So let's figure out how to do that. The first bit should be fairly straightforward, which is just instancing a curve onto these points. So you press Shift A and search for an instance on points node and plug that in right after the simulation output. And for the instance, we'll press Shift A and search for a curve line. Now we can keep the direction on the z-axis itself and plug the curve into the instance. Now this looks great, but we need to give it some thickness, and also if we switch off overlays, they can no longer be seen because they're only curves and not real geometry. So to convert them to real geometry, we press Shift A and search for curve to mesh node and plug that in after the instance on points. For the profile curve, we have to search for another curve circle. We press Shift A and search for a curve circle. Now we can simply plug this curve circle into the profile curve, and we need to reduce the radius down to something like 0.01. That might be too thin, so I'll change it to 0.1. Now for the resolution, I'm going to reduce it to 16 just so that it's a bit faster on my laptop, and I don't think that much of resolution is required. However, we see that all of them are the exact same size, which I don't really like. I want them to have random sizes, both thickness wise as well as length wise, and you can actually do that easily by controlling this scale value on the instance on points node. But remember, the scale value has to be same on the x and y and a different value on the z. So for that, we press Shift A and search for two random value nodes. So the first random value is going to go into the x and y, and the second random value is going to go into the z. But remember, we can't plug them in separately because this is a single dot, so we need to search for a combine xyz. So we press Shift A and search for a combine xyz, and now we can plug all three values in. So this value is going to go into the x as well as the y, and for the z we use our second random value. So let's take this, press Shift D, bring it down here and plug the value into the z socket. Next, we need to actually deal with what the sizes are going to be. Let's plug this into the scale for now, and I don't want there to ever be a situation where the radius is 0, so I'll change the radius min to something like 0.02, and for the max I'll keep it at maybe 0.8. That still might be too fat, so maybe 0.6. Next, for the height, I don't want there to be anything with height 0, so I'll change this to 0.1, and again the max height can be fairly long, so I'll keep it at 1.2. Beyond that, right now the fatter ones are going to be longer and the smaller ones are going to be thinner, and that's because both these random values are using the same seed. So we can just change the seed for the second one, and now it's not necessary that the longer ones are the fatter ones and the shorter ones are thin, because right now you can see this is a fairly long one and it's fairly thin as well. So that just gives it perfect randomness, and you can use these for your future animations. Next, we have to go ahead and make the ends of these cylinders round. For that, we can actually just instance a sphere onto the two endpoints of these curves and then scale the sphere down to the size of the cylinder. So that's not too hard to do. The first thing is shift this to the side, then press Shift A and then search for a join geometry so that we can have both the spheres as well as these cylinders, and then press Shift A and search for an instance on points node. Now, what is the input points that we want to instance all of these on? Remember, if we take this and plug it into the instance on points, these are currently cylinders. So they have multiple points. They have a resolution of 16 down here. So there are actually 16 points on every single one of these cylinders down here and 16 points up here. And that's not where we want to actually instance the spheres. We want to instance the sphere only at the center of each circle on the top and the bottom. And we have that information present over here as the end of the two curved lines that were instanced. So we can actually plug this into the points. However, remember that all of these are instances. Even the output from here are still a bunch of instances, and instances act as single points, and we do not have control over the individual points present within the instance. So if we were to just plug this in, so let's press Shift and search for an icosphere and just plug this into the instance, and for now we'll just keep it a small radius. We'll see how to change the radius in a second. But if we were to take this and plug this into the instance, we wouldn't be able to see it correctly because the scale is being considered for the instances that have been scaled up and down, and that's why we get all of these weird shapes. So the first thing that we have to do is reset all of these, and that's why what we do is press Shift A and search for a realize instance node. So let's plug this in here, and now the scale becomes the same and we can control them properly. So how do we play around with the scale? The scale value has to be the same as this random value over here, because this random value determined the radius of the cylinders. But if we directly plug this in over here, we don't get exactly what we want, and that's because we've actually realized the instances over here. And that way, as we were stating, there was only 1 point for every single one of these random values for each of these cylinders. But by the time we realize instances, there are 2 points for every cylinder. So the number of points that are being used to scale are double the number of cylinders that are there. Each sphere is being changed by a different random value. So we need to fix that. So what we can do is we can actually store this particular random value for every single one of the instances and then use that attribute for the scale. So let's go ahead and press Shift A and search for a store named attribute. Now remember, you don't have to use a store named attribute node. You could just as well use a capture attribute node, but by using this store named attribute, we can also use this random value in our shader editor later on when we go into the shading part of the tutorial. So that's why we're going to actually use a store named attribute, and we need to store the random value for every single one of the instances that were created after this instance on point. So for that, we can go ahead and take this and just plug it in over here, and it gets connected only on one of these lines. But remember, there are 2 lines coming out, so we have to take this and plug it into the realize instances over here as well. And now what do we want to capture? We want to capture the radius, which is a float, and we want to capture it for every instance. So we change this from point to instance. Remember, that's because every instance had 2 points and we don't want that. We want 1 for every instance. Now what is the value that we want to capture? We want to capture this random value that was used. So let's take this random value and plug it into this value. Next, we need to name this attribute something. So let's name it as random integer. So I'll call it RINT. And now we can use this particular attribute that we stored to play with the scale. So let's press Shift A and search for a named attribute node, change the name to RINT, and then we can go ahead and plug this attribute into the scale. Once we do that, the values should be somewhat corresponding, but right now we see that these spheres are a bit too large, and that's because we played around with the radius over here, and we also have a radius for the curved circle. So remember, the radius of the curved circle was considered to be 0.1. So the icosphere has to also have the same radius for this random value to make it absolutely flush with the cylinders. Let's go ahead and give the radius the same value, which is 0.1, and now they should perfectly fit. However, they don't look too great, and that's because the number of subdivisions is very low. Let's just increase that, and there we have a perfectly fitting sphere on the ends of every single one of these lines that look great. Now right now you are able to see the junction between these two, but if you actually switch off overlays and go to your rendered view, you won't be able to see them at all, and they'll look perfect. The only slight issue that you might have is the fact that these are shaded flat. So let's go ahead and just make that shade smooth by bringing this to the side, pressing Shift A and searching for a set shade smooth node. And in fact, you don't have to do that here. You could do that after the entire join geometry as well, because you want everything to be shaded shaded smooth either way. Let's bring that in, and now everything is nicely shaded, and that's good enough. Now let's go back to our solid view and actually set up our camera so that we can just finalize the actual distribute points on faces density before we move on to the shading part of the tutorial. So let's go ahead and select our camera, press Alt G to clear location, Alt R to clear rotation, then RX 90 followed by GZ to just bring it up to about the center of this particular contraption that we created, and then GY to just bring it back. Then we'll press 0 to go into our camera view, and then we can press RY and just tilt it till you're happy with the direction of these lines. After that, we'll go to our camera properties and we'll expand viewport display and increase passport out all the way to 1. Now this actually seems good enough. I'm alright with the density as well as the speed, and in case you feel like you're not seeing the realistic speed, you can change this playback from play every frame to frame dropping, and that way you'll get a realistic idea of how fast these lines are going to be moving through your scene when you finally render out the animation. Next thing that we have to do is make sure that it is actually looping. So for that, we select this object, then go to the physics properties which are down here, and then we can expand the simulation nodes section. Then we have to go ahead and bake the simulation, but we can't bake it unless the file is saved. So you can quickly press Ctrl S and save your file. Now that it's saved, you can go ahead and press this bake button to bake the animation. And when you're baking, make sure that you start from frame 1 to whatever last frame it is. If you keep the start value at the start value that you want to render your animation at, which is like frame 300, the simulation will also start at frame 300, rendering the entire thing pointless. So you have to make sure that you render from frame 300, but you bake it from frame 1 itself. So once the actual bake is complete, as you can see over here, you can then change the start frame to what you wanted the start frame to be, such as 300, and then play the animation. And if you just switch off overlays, you should be able to see it perfectly loop. And yes, it is perfectly looping for me. If I go to frame 600 and then I go back to frame 300, I shouldn't see any difference or any change in these objects. So 300 to 600, there's no change, which means it's perfectly looping. So that is how you actually loop a particle system using geometry nodes. However, we can now start off the actual shading. So let's go to our render properties at the beginning, and I'll go all the way down to color management and change this view transform from filmic to standard so that the colors actually show as the right colors. Now, if you want to see a time lapse of me creating it, you can see this video that's linked right here. In the time lapse, I actually made it neon and glowing with a dark background, but for today's video, I'm going to make a bright white background and have solid colors that are not glowing to be acting as the lines. So that's why I'm changing the view transform to standard and then switching my viewport from solid to rendered. And I'm also going to select the default light and press delete to delete it. Next, I'm going to go to the world properties and just change this background color all the way to white so that we get a perfectly white background. And now I can start playing around with the materials of the cube. For the materials, I have to first set the material, so I can come all the way to the geometry node tree, shift the group output to the side, press shift A and search for a set material node and plug that in. Now we're not using the default material for anything, so we'll just choose the default material from here. Then we'll switch from the geometry node editor to the shader editor, and here we'll go ahead and play around with it. If you can't see the materials, just press period on your numpad to centralize the nodes, and then we're essentially going to choose a random value for every single one of these instances. So we press shift A and search for an attribute node, because remember, we stored a random value for every single one of the instances in this particular attribute node itself. So now we have to change this type from geometry to instancer because we were using it for every instance. Now for the name, remember we called it rint and it was a float, so we're going to be using the factor. But remember, the float random number was not going from 0 to 1. We had changed the values. So we can actually just go back and look at what the values were. So let's go to the geometry node editor, go to where you had the original random value from which you are storing the value rint, and that value has a min of 0.2 and a max of 0.6. So let's go back to our shader editor and change this factor to go from 0 to 1. For that, we press shift A and search for a map range node. And remember, the from min and from max are the values that we just checked. That is a from min of 0.4 to a from max of 0.6. But if I recall correctly, this was actually 0.2. And the 2 min and max is going to be 0 to 1. So that way, this can act as the perfect factor for our color ramp. So let's press shift A and search for a color ramp. And now we can change this from linear to constant and add in as many different colors as you want. So I actually want to add in 4 colors. So I'm going to add in 4 stops by pressing this plus button twice. And now I have 4 stops, and I'm going to move these to 1/4 of the values. So 1 by 4 is 0.25. So I'll take this first slider and change the position to 0.25. Then this second slider I'll change to a value of 0.5, and the third slider I'll change to a value of 0.75. So that way we have 4 equally spaced sliders, and we can give these 4 different colors. Now the best way to select colors is by using a color palette. There are various websites that allow you to choose really nice palettes as such. For example, here on Color Hunt, you could just go ahead and search for a palette. If you just select something, you get a number of different palettes that you can select from. You can actually search for a specific type of palette that you're looking for. So let's say you found a nice palette like this one. You can just go ahead and copy these hex values and plug them into your color ramp. So let's start with this one. Just select it and it gets copied, then over here, just select your marker, select the color, then go to hex value over here, and then just press Ctrl V, enter. And that way you get that exact color. Now you can do that for the other 3 colors as well. Select it, select this, click here, change the hex value by pressing Ctrl V, and that's it. Once you're done with adding in the 4 different colors, you can take this result from the map range, plug it into the factor, and then this color and plug it into the base color. Then we can also increase the roughness all the way to 1 so that we don't get any type of reflections, and you have yourself this type of a motion graphic that perfectly loops. Now you could do this with various different color combinations, and it's as simple as just taking this color ramp, pressing Shift D so that you can use it for later purposes as well, plugging this factor in, taking this color and changing all the hex values for this new color ramp as well. And that's actually all there is to it. If you're happy with what you see, you can go ahead and press render animation. I really hope this tutorial helped you, and now you understand one method of creating looping particle systems using simulation nodes. I've been trying to do that for a while, and this is just one method that I figured out. The time lapse of me actually trying it out to see if it works is present on my channel, and if you're interested, you can go ahead and watch that time lapse. Beyond that, I'll be continuing to post tutorials itself every single day, so I'm sure there's going to be a lot for all of you to explore and learn from. So if you watched so far, thank you so much for watching. The watch time really helps, and until the next video comes out, keep creating and stay creative.